Okay, well, welcome to this session, which is called Getting the Most from Modern Java. My name is Simon Ritter, and I am the Deputy CTO of Azure Systems. Now, the idea behind this presentation, as the title would really suggest, is how to understand the new things that have occurred in Java in terms of features. And because I've only got 30 minutes for this session, I need to kind of restrict this a little bit. So what I've decided to do is to go through the new language features that have occurred since JDK 11. So JDK 11 was the last long-term support release, and obviously we've had a number of releases since then because we have JDK 15 currently, and literally this month, because we're now in February, we'll have JDK 16 being released as well. So we've had several releases since then and a number of new language features. So what I've decided to do is just focus purely on the language features. There are lots of other things that have gone into Java. There's a number of API changes, a few changes at the JVM level, but really from the Java language perspective, what we're going to talk about are all the great things which we've seen introduced in the last, well, nearly 2.5 years, isn't it? Yes. Okay, so let's start with JDK 12, very logically, because that was the next release after JDK 11. Now, one of the things that was introduced here was the idea of switch expressions. And this was quite significant, not just from the point of view of what it provided in the language, but this is the first what's called preview feature in OpenJDK. And the idea behind a preview feature is to enable a new feature to be added to Java, but not making it part of the standard straight away. And the reason for that is that by doing it that way, people can have a chance to experiment with a feature, they can try it out, they can kick the tires on it. And then if they think that there's something that does need to be changed and they're not quite happy with it, feedback can be provided, and then the developers can sort of review that and decide if they want to make some changes. And as we'll see, that seems to be working very well. So preview feature, it's kind of like the incubator modules that were introduced a while ago for new API features. And again, so you could introduce things without making it part of the standard. So switch expression, first preview feature. The reason behind this was if you look at the switch statement, which we've had right from the very beginning in Java, there's a number of things which make the use of a switch statement a little bit more tricky and potentially error prone than would be really ideal. And so the syntax of the switch statement was inherited from the C language, because a lot of Java syntax is based on the C language. And that was great for C because the way that the switch statement worked in C was designed around the idea of a language which is more of a systems programming language, operating systems, compilers, those sort of types of things. Because Java is much more of an application language, the way that the switch statement works isn't quite it leads to some potential problems. So one of the things that we have is that every case statement needs to be separated. So you've got to have case A, case B, case C. Okay, well, it's not that big of an overhead, but it's just a little bit more clunky than we really want. Then the other thing is we've got to remember to put a break statement in each of our case blocks. And that one is a bit of a big one, because I know I've done this in the past. I'm sure most people have done it who've used Switch, is you've forgotten somewhere to put a break in. And then because the syntax means that you can do that, what happens is that you will fall through into the next one. And then you do something you don't expect, and the application doesn't work the way you expect, which means you've got a bug. And then trying to find that can be quite difficult because it's a little bit of a subtle one. So that's one of the problems. And then also the scope of local variables is not always intuitive when you use them within a case statement. So this was the rationale behind this. They wanted to improve this. And so if we look at how we typically use a switch statement, this is very typical kind of example. What we're doing here is we're taking one variable, day, we're going to switch on that, and then we want to assign a value to another variable, number of letters, based on which day it is. It's a sort of like multiple if then else type of thing. And obviously that works very well, but we have a lot of code here. So we look at this, it's very verbose. We've got case Monday, case Friday, case Sunday. Then we have to assign number of letters equals 6. And in the next block, we've got case Tuesday, number of letters equals 7. So again, there's a little bit of a problem here because what we can see is that if we forget to assign number of letters, we again get a subtle bug that would be introduced, and it's a bit, more difficult. So the idea behind the switch expression is to simplify this a lot and make it much more robust in terms of eliminating potential errors. If we look at what we get in terms of the new syntax, straight away you can see that it's much more condensed. There's a lot less text that we need. And so what we can see here is the first thing, because it's now a switch expression, we can assign the return value to our variable number of letters. And we only need to do that once. So we eliminate that potential of error by saying, take the result of the switch expression, assign it to number of letters, and then do that once, and that's it, forget about it. Then we see that in terms of the case statements themselves, the engineers have obviously looked around and they've discovered this incredibly powerful feature, which is called a comma-separated list. So now we don't have to have a separate case Monday, case Friday, case Sunday. We can have case Monday, comma, Friday, comma, Sunday. That on its own was well worth the effort to me. Now, what they've then done is to borrow some of the syntax from Lambda expressions and use the arrow to indicate that the right-hand side of the expression is the cases that we're interested in, a match against, and then the right-hand side is the value that we're going to return from the switch expression. And clearly, there may be situations where the value is invalid, in which case we can also, with the default there, you can see that we can throw a new illegal state exception. So we can still throw an exception if we need to, either return a value or throw an exception. But again, nice syntax, very condensed, much easier to see what's going on, much less error prone, because again, we don't have those break statements, so there's no chance of falling through. We'll always see what we're returning, all good. Now, what we can do, and I'm not sure I'd really recommend this, is you can actually combine the old style switch statement syntax with the new style switch expression. So you could do something like this, where you do switch day, case Monday, case Friday, case Sunday, and then we use break to indicate the value that's going to be returned. And so we have break 6, break 7, break 8, and so on. And okay, you know, I don't really like this syntax that much because, again, it sort of it introduces the possibility of less readability and potentially some a little bit more error prone, perhaps. The other thing with switch expression is going back to the idea of local variables. And what you couldn't do in the past with the switch statement was to reuse a variable within different cases. And so the scoping of those variables didn't work. Now with the switch expression, as we can see here, you can actually form more complex code, and you can use a block of code with the braces and say var x equals compute from, and then in case 2, you can do var x equals negative compute from. And that will work now, and you can reuse the variable x in both of those cases, and there's no issue over the scoping of those and not being valid. So that's all good. Again, I wouldn't recommend this syntax because once we start getting into code blocks, what I would recommend is to extract that code out, put it into a separate method, and then call the method from that case. But there you go, you can do it. Okay, so that was the big things in JDK 12. Now let's move on to JDK 13. Now the 6 months of development, what did we get there? Well, really only one sort of change in terms of the language. And this was what are called text blocks. Again, this is a preview feature, so introduced without being part of the standard, so people can provide feedback. Now, the problem we've had in the past with Java is that we can clearly define strings, but how we define strings is not always as easy as we really want it to be, especially if you want to have multi-line strings. That's the kind of big bugbear that people have. And in the example here, obviously what we want to do is have some sort of HTML tags and lay it out with indentation and new lines and so on. If we wanted to do that in Java before, it would be very complicated. We'd have to concatenate things. We'd have to put escape characters in there, \n, \r, those types of things. And it just becomes more hard work. What we needed was the ability to define a string where we didn't need lots of escape characters. We could simply say, okay, here's the start of the string. Everything after that is the string I'm interested in, including new lines, including any escape characters, whatever, and then have something that terminates that string in a way that the compiler can understand. And that's what a text block is. So now, rather than using a single set of double quotes, we use 3 double quotes together. So you can see here we've got string web page equals 3 double quotes. And one of the important things about this is that you can't start the string directly after those 3 double quotes. So you have to start the string on the next line. And here we've obviously got some HTML tags. indented nicely, all very good. And then we terminate it with another 3 double quotes. Now, if you wanted to put 3 double quotes in your string, then obviously that's a situation where you do have to escape it. So then you'd have to use a backslash in front of at least the first of those 3 double quotes. You can use 1, 2, or 3 backslashes. Realistically, you're only going to use 1, but you could use 1, 2, or 3. The syntax will support that. Now, if we look at the output from this, what we'll see is maybe not particularly what you might expect. So what we see here is we run the web page and we see the HTML tags indented the way that we want them to, because we're using 2 spaces here. Ooh, never use tabs. We use 2 spaces, but what we're doing is allowing the layout of our strings to be the way that we would like it to be from the point of view of readability. What we don't have to do is push it all over to the left-hand side so that we got it aligned with the left-hand margin. That would be a little bit difficult in terms of readability. What we really want to do is what we've got here, where we can line up the string underneath the start of that, so it's clear what's going on and it follows the layout of the rest of the application code. So the way that works is through what's called incidental white space. And in the case of this example here, what's happening is any white space up until the start of the first character of the text on the left-hand side is treated as incidental white space and eliminated. And that way, what happens is that you can see the HTML and the closing HTML tag are left justified against the margin, and then we still get the right indentation in terms of 2 characters and then 4 spaces, sorry, 2 spaces and then 4 spaces to get the right indentation there. So we're eliminating that incidental white space. Now, what you can do is if you want to shift things over and add more white space in front of it, you can actually shift your tags over and make it sort of slightly further over to the left, and that will or over to the right, and that will introduce more white space. So different ways of doing that. Switch expression. Hang on. I just talked about switch expression. That was in JDK 12. So why am I talking about switch expression in JDK 13 again? And the answer is that there was feedback on this particular feature, and the developers said, that's good feedback. We will make a change based on that. When I showed you the combination of the switch statement syntax along with the switch expression syntax, what we were doing there is we were saying case Monday, Friday, Sunday, break with a value of 6. Now that will work because the break statement can be used on its own in a case statement, or it can be used with a label, and you can break out of a loop or a case statement to a label that's been defined elsewhere in the code, a bit like a goto. Must admit, I've never used that particular, well, maybe I have. No, I don't think I have. But anyway, I digress. So people said, well, yes, you can do it, but it's a bit confusing in terms of the syntax because you can never start a label with a number. So yes, the compiler knows that in this case, it's returning a value, but it was still a little bit confusing to people. And they said, don't really like that. So the developer said, okay, we'll make a change. And rather than using break, we'll use yield. So now you do case Monday, case Friday, case Sunday, yield 6, and that gives you the answer you want, and all is good. So it's a feedback from developers, and they've said, yeah, we'd like it to be a little bit different. And the developers have said, okay, we'll take that feedback on board and make a change. JDK 14. Now, JDK 14 introduced a couple of things, and I've got to say that probably in terms of the most recent releases, this is probably the big one with new features. So the first of those is around the way that we use simple data classes in Java. And if we look at the existing kind of code that we might write now, we would do something like this. So we're creating a class called point, and effectively it's a tuple with 2 values, X and Y. And in order to do that, we've obviously got to declare 2 instance variables, private, final, double X, double Y. Then we have a constructor that takes 2 doubles. We then assign those doubles to the instance variables of the class. Then we've got accessor methods, so we can do public double X, which returns X, public double Y, which returns Y. And if you look at that, you've got, what is it, something like 16 lines of code, maybe not with the white space, but probably good 12 lines of code just to create a tuple. And that's, you know, a lot of work when it's something as fundamental as this. So what JDK 14 I do remember that, JDK 14 introduces is the idea of records. This is, I like this. This is a really powerful thing and makes life a whole lot easier. So now what we can do is we can say, let's create a new class, but in this case, it's a record class, and it's a new type of class within Java. There are some subtleties about this, which I'll go through in a moment. But essentially, we're creating a class which is a record, and it's going to be called point. Now, what we can do here is we can simply say point and then use the brackets to indicate the values that we want this record to encapsulate. So we've got double X and double Y. Then we simply have a set of empty braces, and the compiler will generate all of the necessary code that is required for that tuple without us having to do any of it manually. So we get the same effective code as we had on the previous slide. So we get a constructor, we can pass values to it to when we instantiate an object. We can access those variables through X and Y. Everything will work in exactly the same way. Now, there are situations where not having a constructor may not be ideal because we might want to do some additional checking inside the constructor. And in that case, we can use what's called a compact constructor. So here what we're doing is we're saying, let's define a record called range, again, two values, low and high. And what it's going to do now is have a compact constructor, which is called range. Now, we don't have to have the brackets with the values specified for them. So we don't have to replicate the int low, int high there because we've already got those in the definition of the record. So that's one nice thing. That eliminates a little bit of bloat. And then within that, we can define the body of the constructor, and we can have an if statement, if low greater than high, throw an illegal argument exception, and okay, that all works the way that we want it to. So we've got more flexibility in terms of what we can do with records. Okay, a few additional things about records, because although records are like classes, there are some subtle things which we need to understand. So the first thing is that the compact constructor can only throw an unchecked exception. Can't throw a checked exception because there's no syntax in there in terms of defining the compact constructor to say it throws a type of exception. So syntax for that doesn't allow specifying a checked exception. In terms of the standard methods that you have with the object, equals, hashcode, and toString, you can override those within a record. So there's no problem with doing that. You can actually override them and everything will work exactly the way that you expect it to. Base class of all records is java.lang.record. So that's a new class that's been introduced. And this is also a preview feature. This again sort of comes back to the idea of preview features that allow you to include things without making it part of the standard. And this was a sort of specific thing that needed to be done, because if we added record as a part of the Java SE standard, the way they did it before was to immediately deprecate it so that they could potentially remove it if it needed to be. Now we have them as part of the preview feature, so they're not actually part of the standard straight away. Records don't follow the Java bean pattern. So that's something that's a slight subtlety in terms of the way this works. So the thing here is that rather than using the bean pattern, which the accessor methods would typically be called getX and getY, they've decided to use the shorter version, which is simply X and Y. So you don't have the get part of that. I personally would prefer to see the bean pattern, but it's one of those things where, if you ask 100 developers, 50 will go one way, 50 will go the other way. So it doesn't really matter, but it's just something to be aware of. Instance fields cannot be added to a record. So you define obviously X and Y in the example we had of the point, low and high in our range. You can't add any more instance variables to that record. There's no way of doing that. However, if you want to, you can do that for static fields. So you can add static field to your record, but you can't add an instance field unless it's part of the record itself. And records can be generic, so that's all good. Instance of. So another thing that we got in JDK 14. If we look at the way that we use instance of, where we passed an object, but we don't know necessarily what type it is exactly, and we need to test that in order to determine how we want to use it. This is a very simple piece of code, the way that we would typically do that. So we say if obj instance of string, and then within the body of the if statement, we say string s equals, and then we cast our obj reference to a string because we know that it is an instance of string. So when we do that explicit cast, there's no danger of it getting a class cast exception. So there's no problem there. And then we can print out using the methods of the string to say s.length, because now it is a string in terms of our reference. And so we can use that without any problem. In terms of pattern matching with instanceof, again, it's a preview feature in JDK 14. What we can now do is extend that syntax slightly. So we can say if obj instance of string, but then we'll add a variable to the end of that, so s. If obj instance of string s, at that point, we don't have to do the explicit cast anymore. The compiler is going to effectively do that for us and provide us with a reference that we can then use within that if statement. So here, in terms of the true branch of that if statement, we can say system.out.println s.length, because we know that that's true. So it is an instance of string. It's been assigned to s. And so we can use the length method on that and everything will work. However, if we tried to use s in the else branch of the if statement, because because obj is not an instance of string, we won't have an assignment to s because it isn't string. So we couldn't use s in that situation. The compiler would reject it as an error. We can do some more clever things with that. So we could do something like this. We can say if obj instance of string s, and then do an AND operator and check to see if the length of that string is greater than 0. If it is, then we'll print out the length of that string. Now, the reason we can do that safely is because in the case of the AND operator, the left-hand side is always evaluated first, and only if that evaluates to true will the right-hand side of the operator be evaluated. So here we can safely say if obj instance of string, if that's true, then it is a string. So then we can call the length method on s, and that's a safe operation. However, if obj is not a string, that will result in a false evaluation, and we will never call the right-hand side, so we don't need to worry about trying to call length on something that isn't on a string. Obviously, if we tried to do that with the OR operator, that wouldn't work, because in the case of the OR operator, we have to evaluate both sides of the operator, because either side will result in true, or if either side results in true, then we go through and do whatever is in the if statement. So in this case, we couldn't do that, and we get a compiler error because, even if obj wasn't a string, we would still try to call length on s and it wouldn't work. And then there are some slightly odd things where you can do that and not necessarily get the results or it may not be clear exactly how things are working. So you could do something like this. You could say if O instance of string s and s.length greater than 3, if it's not that case, then you can return. Otherwise, you can print out s.length. So we know that in the case of that if statement, we've evaluated it, and we know that s is a string. So we can then call length on that and print it out. So that will work, even though you might think, oh, hang on, so where's the scope of that s actually going to work? Anything after there is true. Text blocks. Again, these were introduced in JDK 13, but now because it was a preview feature, feedback, also more development went through. And so what they've done here in JDK 14 is to add 2 more escape sequences. Pretty straightforward, pretty simple. One of those is to use the backslash at the end of the line and allow you to continue on without having a new line in the string that's generated. This is very similar. If you've done shell programming, then you'll know exactly what this is like. And then also you can have a backslash s, which doesn't remove the trailing spaces. So we'll keep those trailing spaces in there and they will become part of the string as well. JDK 15, so the current release. So JDK 15 introduced the idea of sealed classes, and this is JEP 360. Now, in Java, obviously, it's an object-oriented programming language, and it has the concept of inheritance. So what we can do here is we can say we have a class called shape, and we want to inherit from that. So we can define triangle, square, and pentagon, which are subclasses of shape. That's all well and good, but what we don't have is any control over which classes can subclass a particular class, other than making it final. So if we make a class or an interface final, then we know that nobody can subclass that. So it's a kind of binary thing, all or nothing. Either you don't make it final, in which case anybody can subclass it, you make it final and nobody can subclass it. What sealed classes allows us to do is to have control over which classes can subclass a given class. And you can think of the final as being the ultimate sealed class, as in, it's completely sealed and nobody else can subclass it. Interestingly here, although they're called sealed classes, it also applies to interfaces. And there's some quite complicated logic as to why they use the term class here rather than type. I actually tweeted about this. So if you look back on my Twitter feed, you'll find there's a link from David Delabassi, who replied to my question, and it links to an explanation of why it's called sealed classes rather than sealed types. Now, in terms of how this works, is it introduces two new restricted identifiers. So these are sealed and permits, and restricted identifiers are things like var, where you can use it without it preventing you from using it as a variable name. So you can still use sealed and permits as variable names, but in certain situations where they're used, then they have they're used as an identifier they're used as a keyword rather than identifier. Also has one new reserved word, which is non-sealed. Now, because this has a hyphen in it, this is the first reserved word ever to have a hyphen in it. So there's no backward compatibility issues with that. So you can't use a hyphen in a variable name in Java, doesn't cause a problem. Classes that are using sealed classes must all be in the same package or module. So there has to be that visibility in terms of packaging and modules. So what we can do is we can do something like this. We can say public sealed class shape permits triangle, square, pentagon, and that will allow us to do the same thing that we had before. So we have our shape as a superclass, triangle, square, and pentagon as subclasses. However, what we now can't do, which we could have done before, is to try and have another class called circle inherit from shape. Because if we try and do that, because it's not listed in the permits set of classes, then it will actually fail and you'll get a compiler error. So we're now saying only those three classes, triangle, square, and pentagon, can subclass shape, circle cannot. Now, once we have a subclass, we then have to have a bit more information because we have to be explicit about the inheritance capabilities of each of those subclasses. Because obviously, if we've got a sealed class at the top, what does it mean in terms of those subclasses? And there are three separate things that we can do here. So the first is we could restrict the subclasses to a defined set. So we could actually continue that, that sealing with a permitted set of classes. So we could do public sealed class triangle, and then we could say, okay, that permits equilateral and isosceles and extends shape. In terms of another alternative is we could actually prevent any further subclassing. So we could make it final, and that effectively seals it completely, turns it off. And then the third option we've got, which is where we use that new reserved word, is to say that we can unseal it. So make it non-sealed. So now anybody, any class can inherit from pentagon. So we've said, okay, that in terms of the shape, we're restricting it to, so non-sealed class pentagon extends shape. Second thing here, or another thing here, is the idea of a second preview of records. So they extended the preview. They haven't made it part of the standard yet, but they've added a little bit more functionality. And the idea here is to say that we can now have local records. So it's like a local class, and it's implicitly static. This is quite useful because here's a very good example of how we could use that. So we've got a method, find top sellers. And what we're going to do is we're going to say, okay, we've got a local record called sales, which consists of two things. It's a tuple, it's got seller, and it's got sales, which is a double. And then what we're going to do is we're going to use the sellers list that we've got, and then we want to process that. So we're going to use stream with some Lambda expressions. And what we first do is we map that seller into the sales. And the sales will take the seller that we've got and then calculate the sales that seller had in a particular month and make that the other part of the tuple. Then we can sort that based on the sales of each of those sellers, and then we can map it back to the sellers and collect it in a list. And what that will do is, because it's sorted, we can see the ordering of the sellers based on how much they've sold in a given month. And by doing that with a local record, it actually, eliminates a whole lot of code that we would have to do otherwise. It makes it much more concise and much more subtle. Finally, just briefly talk about JDK 16 because this is coming out later this month. And not really that much in here. Records is now a feature of Java SE, so it's no longer a preview feature, it's now a full feature. One minor modification where what they've clarified things, so inner classes can now define both implicit and explicit static members. And the impact of that is it allows an inner class to declare a member that is a record class. So that will work. Pattern matching instance of is now a feature of Java SE, so there are no changes needed from that. It's now been moved from preview feature to full feature. Seal classes have been moved into a second preview, and so now there's a little tiny sort of thing about the standardization. We now have what are called contextual keywords rather than restricted modifiers and keywords. But since I'm running out of time, you'll have to look that one up. Just to summarize then, basically, we are moving Java forward faster. I think 6-month release cycle is working really well, getting lots of new little language features, tidying up things, simplifying a lot of syntax, really good stuff. Preview features, incubator modules working really well in terms of allowing those features to be developed in the open so people can provide feedback. Lots more to come. There's lots more things in Amber. We've also got bigger projects like Valhalla, inline types. We've got Loom with virtual threads and so on. And I think it's fair to say that Java is continuing to deliver features that developers want and need. If you're looking for a build of OpenJDK, either free or with commercial support, then please go to our website here at azul.com. And like I say, there are free downloads to be had. And with that, thank you very much.